Hi everyone, it's Mrs. Summer here to discuss atomic radius trends on the periodic table. The goals of this lesson is that you will be able to identify the atomic radii trends on the periodic table, rank atoms based on the atomic radii trend, predict the atomic radii of an atom based on its location on the periodic table. Radius is the distance from the center of the nucleus to the edge of the electron cloud. So we have our nucleus here, and this is our outer ring. It's the distance here between those two. Atomic radii are usually measured in picometers. The atomic radius trend, group trend. Atomic radius increases from top to bottom. The reason, more energy levels are added. If we look at sodium has 1 and 2, so it has 3 electrons. Now we look at francium all the way down. Francium has a lot more energy levels. So from its nucleus all the way to the end, it's going to be a much greater distance than from the center of a sodium atom to its outermost electron ring. The period trend, or going left to right or right to left across the periodic table, is that the atomic radius increases from right to left. The reason is nonmetals have more protons than metals. So the more protons, if we look at fluorine has 9 protons and 9 total electrons. These 9 protons have a positive charge. Well, remember, positive attracts to negative. So these 9 electrons that are going around are 1, 2, 3, 4, 5, 6, 7. 9 electrons. Well, these 9 protons are pulling in. They are attracted to each other. So they have the nucleus has a stronger electromagnetic attraction to the electrons orbiting it around it. If we look at lithium, which is in the same period 2 as fluorine, lithium has 3 protons. It has the same number of orbitals as fluorine, but it only has 3 electrons orbiting it. This charge is going to be a lot less, so it's going to be a greater distance because there's not as big of a pull. So therefore, fluorine's atom has a smaller distance between its nucleus and its outer shell than lithium does, which is the reason why the atomic trend for atomic radius is that the atomic radius increases right to left across the period. On your own periodic table, draw red arrows like this, going down and increasing right to left. Now you try. Circle the element with the larger atomic radius: sodium or chlorine, bromine or iodine, calcium or strontium. So if we're looking between sodium and chlorine here, sodium is going to have the larger atomic radius because it increases right to left across the period. Bromine or iodine, bromine is here and iodine's right here. The atomic radius increases as we go down the period, so iodine would have the larger atomic radius. Calcium or strontium. Calcium is right here, strontium is right here. Strontium would have the larger atomic radius.